there has been a lot of changes since really our last summit in early March. And both changes in terms of the regulatory side, but also the scientific side. It's been a very, very active time, and I want to highlight some of those. And, you know, Francis mentioned a lot of the cool giveaways, but really a primary goal of the summit is to be educational and almost provide kind of a state of the science in terms of what's going on for PFAS, and look forward to the future, because we know with as much changes as there has been within the last 7 months or so, we know that's even going to accelerate, and there'll be more changes by the time we hit phase 3 of our PFAS summit. So I just want to highlight some of those today, and this is by no means comprehensive, because I think we could spend at least an hour or so going over each one in detail. But to remind you, just a few short months ago, Summit 1 in early March, very successful in terms of the engagement that we had, and a great lineup of both internal and external speakers talking about the state of the science from their expertise, in water testing, in atmospheric testing, personal care products. So, very fun time. And as we reflect on that, we look forward to what's being presented over the next couple days. So just a few things, really, this kind of incorporates all of the changes and major changes in 2023, not just since our March summit, but of course the big one in the United States was the proposed drinking water regulations. So those were announced in mid-March, just really a few short days after our first summit. Had been anticipated, really much anticipated in the year or so leading up to it, but with the eventual announcement of this proposed regulation. So that was down to 4 parts per trillion, or nanograms per liter for both PFOA and PFAS. 3 other PFAS mentioned, 4 other: PFNA, the hexane sulfonic acid, PFBS, and Gen X, or HFPODA. Those ones are a little bit different in terms of not a proposed single concentration, but more looking at a hazard index criteria. So as of today, those levels are still in the proposed stage. It is anticipated that they will be finalized regulations, enforceable regulations, by the end of this year or early next year. So that's really, from a regulatory stand, one of the major announcements, in this case impacting the United States. More on the regulatory side in the United States was the EPA finalizing a rule with regards to reporting, and this would be requiring all the manufacturers and those that actually make PFAS-containing products from 2011 forward to report on a number of different things, such as their identity and uses, and environmental health effects, as well as release. So the impact of this really, I think, will help us understand better what's being used in commerce, and then also what could be emitted into the environment, and eventually flow through those PFAS life cycle compartments and end up in humans and wildlife. Impactful there, and as that database grows, I'm sure we'll have lots of interesting learning from that. And then also too, this in the summer, major impact, an announcement here with regards to settling the drinking water lawsuits by 2 of the major manufacturers, in the billions of dollars. And not only that, but I think if you look at the quote here from the Routers article, with respect to the fact that the settlement would provide funding for a significant period of time for testing of water. So not just finished water, but testing of public water systems. So very important there, and very large amount of money set aside for testing. And then on the European side, the announcement in February about the proposed ban of up to 10,000 PFAS. We're still waiting to understand what that actually means in terms of what can be imported and used within the European Union. But certainly that has the potential for a very significant impact globally, because it would affect folks that are making PFAS containing products and importing them into or exporting them into Europe. So again, I think probably early in 2024, we'll have a better idea as to what that means. But to have that really broad blanket ban on 10,000 or more PFAS, I think, as the article says on the right-hand side, could have a staggering impact, not just on the United States, but all over the world. So, as Francis alluded to in the introduction, what we've seen a lot in the recent months is this move away from just drinking water and the concern about drinking water and into other aspects of the PFAS life cycle. So, for us, often, if we look down at the bottom right-hand corner, there is concern about the levels that get into humans, right, into our blood, but that can also account for wildlife as well. But to truly understand how they're getting in there and how we can mitigate them, then we need to understand really the root cause for contamination. And that starts all the way at the top of the graphic in terms of industrial production and flowing through different cycles or compartments such as consumer goods or landfills and composting, and then eventually into food or water or the indoor environment. So really, as we see it, a major push into understanding more of these upstream compartments to drive to root cause as to how chemicals land in our blood. So big one here from Europe, looking at food. This actually was enforced very early in the year, but really kind of the first attempt globally to try to regulate PFAS in food. And I've got some snapshot here of some levels really covered PFAS, PFOA, PFNA, and hexane sulfonic acid, primarily concerned with protein-rich materials such as eggs and meat and fish, and here at various levels. Interestingly enough, too, is they have some suggested levels where they're not at the regulatory level, but if they are detected, then perhaps these are levels which it is prudent to do some more investigation. So I think globally there's a lot of other countries that are looking towards the EU and these regulations to start to develop their own regulations surrounding food. And I'm not sure, but potentially for the EU, this is the start of regulating PFAS in food, and they may be looking for other matrices later on as well. In addition, the AOAC, this was earlier this year, really a committee that was led by Susie Ginaldi from the FDA, led a group of experts, global experts of PFAS and food, to come together and establish these standard method performance requirements, or SMPRs for PFAS, focused in on those 4 PFAS that were regulated by the EU. But this developed a very good set of criteria in terms of data quality to help establish methods. So this has just been finalized, I believe, as of last week, but finalized in terms of these criteria. And now there's a call out for methods for people to build their methods with the goals of achieving these criteria. And here is just a small snapshot of some of the target LOQs in kind of non-meat matrices there. So this will have a large impact in terms of the methods that are being developed to analyze PFAS in food. But then, of course, we expect a very large database and a very large number of studies examining PFAS in food products. So then when we look at how PFAS get into our food, kind of a more of a direct case or traditional case on the left-hand side, showing uptake from a contaminated either soil or water system. But then on the right-hand side, a more indirect case, And this is something that, even though if you see the date actually on the graph in the bottom right-hand corner from 2007, we've known for quite a while that PFAS are in food contact materials and can potentially migrate into food. But this is something that we have seen a bit of a resurgence as we progress into 2023. So more on the direct side, I realize all of these newspaper articles were from last year, but they are still relevant. Looking at PFAS in contaminated agricultural fields, which could then impact crops and livestock. But then the question of, well, how did those fields become contaminated in the first place? And I don't have a screenshot of it, but Michigan State held a very successful symposium just early in October, looking at this exact issue. So, again, as we drive to root cause to try to understand why livestock and crops may become contaminated, it is requiring us to go back further up the kind of exposure chain to look at other compartments in the PFAS life cycle. So that was the direct side. On the indirect side, and I mentioned food packaging, you'll notice even though we know, or we have known for quite some time, that PFAS are in food contact materials, you'll notice here is an article from The Guardian from just in June, right? Plastic containers still distributed in the US have PFAS in them. And then here, a peer-reviewed paper from earlier in March in 2023. Then we've got the study looking at how some of these directly fluorinated containers can act as a source of PFAS to food, and you'll notice the various food items on the x-axis there. So again, issues that are coming to the forefront again after several years. From a regulatory standpoint, we will see how this goes in terms of which countries and states may implement. Interferences in food, we knew for a long time that there was potential some bile acids in food that could act as PFAS interferences. But here's a paper that was published earlier this year that we've got some various interferences for the lower chain carboxylic acids. And then more recently, in early September, a group from the FDA published an article in LCGC looking at some different interferences, again, impacting different PFAS. Fish consumption warning. Again, this one got a lot of attention in terms of folks that catch their own fish, and potentially could have a significant increase in cancer, just even from a small dose. And then, as I wrap up here, this is sort of loosely associated with the kind of the whole packaging idea. But again, I'll bring you back to a paper that Amy Rand did during her PhD with Scott Maybury from 2011, showing that some fluorinated plastics could act as a source of PFAS. Fast forward to this year, where there's increasing attention on potentially leaching out of those plastic bottles into our foods, but also into liquids that may be in contact. And you may remember there was a pesticide that got a lot of attention from containing PFAS, presumably leaching from those bottles. And again, the EPA is starting to revisit this issue. So as I summarized that, and that was kind of a quick snapshot to show you some of the major changes since our last PFAS summit, very important changes in terms of the regulatory and scientific landscape. Some of the impacts of those regulatory changes, particularly that EU ban, still uncertain, but we are certain it is going to have a major impact in terms of what folks are going to be selling, and then ultimately what gets out into the environment, and then into humans and wildlife. And then also too, whereas several years ago the focus was primarily on drinking water, Now we are starting to move up the exposure chain to look at those other compartments to kind of drive to root cause and understand, the entire PFAS life cycle.